Welcome to the second feedback video. We're going to give feedback on your main results, but also to your intermediate results in these videos. This week we have received 7 submissions for assignment 2, consisting of nice nulled pictures, videos, and of course the hurdles involved while dismantling your case products. There were 7 deliverables, of which 4 were shared via the Miro board. We will run through them one by one and discuss pointers and key takeaways. Next, I will discuss the main takeaways or main takeaway from the dismantling process. And finally, I will tell a little bit more about the upcoming assignments. So let's have a look at the case study from Asife Pishon. She dismantled a Sony computer mouse, which included a roll-up wire system, making the mouse very transportable. The bodywork was difficult to dismantle due to the rows of snap fits and hidden screws. Let's start with the materials. A lot of materials are made out of plastics. And here you can see some sticky plastic piece where softeners are added, making the part flexible and soft. Over time, the softener will evaporate from the material, leaving the sticky feeling. And when you want to refurbish this mouse, you need to replace these softer parts, and as a designer, maybe leave them out completely. Sticky plastics are one of the main reasons people will replace the product before technical lifespan has ended, and instead of using it for a longer period. Another issue which could be problematic during the disassembly is the high forces needed to disconnect parts. The buttons on this computer mouse were clicked in too hard, which made the part break during the dismantling. Same thing accounts for this row of snap fits, which was difficult to disconnect. You could even wound yourself by putting so much force with your screwdriver on the mouse and cut yourself by pushing it through. This step took more than 3 minutes before the parts were disconnected, and that's way too long for clean dismantling and for refurbishment or remanufacturing processes. On the other hand, you noticed you forgot about one of the screws which made parts stick together next to the snap fits, and that's something to keep in mind. Probably it wasn't clear how things were connected, which flawed the design for disassembly. Screws are sometimes hidden, and unhide those screws make it easier for the repairman to repair it. Last but not least, the mouse also makes use of an automatic wire retraction system, like in your vacuum cleaner. And this also means there's a spring inside, which makes it difficult to reassemble after opening. Asife used an analog kitchen scale to measure the weight of the parts, and these scales are often not precise enough. So I would propose to use a more precise weighing scales up to 0.1 grams instead of the kitchen weighing scales, which have a precision of 1 gram. So let's move on to the next one, the Gardena grass shear. And Liz dismantled this grass shear, which contains some screws that were hard to reach and therefore difficult to unscrew. Liv had to ask for a second pair of hands while dismantling and needed extra force for separating most parts. The first issue that Liv faced was the significant number of recessed screws that needed to be unscrewed to take apart the housing. She mentioned that she had to buy one screwdriver, an extra screwdriver for the deeper screws, and this shows a flaw in the design for disassembly. While trying to unscrew the screws with one of the screwdrivers, one screw was destroyed, which resulted in Liv's decision to use some violence here. And she asked the second person to hammer in an L-shaped screwdriver to remove the screw. After destroying another screw and exerting lots of extra force, Liv came to the conclusion that you can't really exchange the motor, nor the PCB, nor the battery. You need to exchange it as a whole package. The system is modular and large modules can be replaced, which is easy and good for repair. But a nice example of designing for modularity, but to what extent is the designer's choice larger or use the designer choice to use larger or smaller modules. Keep that in mind in your next design. So now let's move on to this direct decorative disco ball that was dismantled by Elba. At multiple steps of the disassembly, she encountered components that were glued together. With quite some force and patience, she managed to disconnect the parts. However, when dealing with a product that really should not get damaged, we advise you to use a hairdryer. The heat will loosen up or soften the glue and enable separation without damaging the product. So, the hairdryer is a very good tool to have lying around. Finally, you notice that there were no material indications on this part, for instance. So it can be hard to know which type of plastic it is exactly. For the hotspot mapping tool, you don't exactly need to know what material it's made of. But for episode 3, you're going to build your own bill of materials, where you're going to work with the circularity calculator. You need to know more specifically what material the part is made of. Finally, we will consider this very cool nutcracker that was dismantled by Tom by Nachter. Tom dismantled this product in a record time of 1.5 minutes. However, because this product is already so fit for disassembly and consists of mostly one bio-based material, it's not that very suitable for this course. If you can, it would be valuable to switch to a different product that is a little bit more complex, has different types of materials in there and different types of connections. So while dismantling your products, you always learn about good and bad design, the struggles at the end of first life and how components are connected. By actively dismantling, you will become a more practical designer, improving yourself with every disassembly. When you do this with an eye for issues involved during dismantling, slowing down the process of dismantling, each time you will get more professional and becoming a circular practitioner. So let's see what's upcoming. For now, you have finished assignment 1, the value capture example, and assignment 2, the disassembly of the case product and shooting the video. In the upcoming assignment, you will fill in the disassembly table, which you can download. It's called the Hotspot Mapping Spreadsheet from the Profet website. As a tip for everyone, for assignment 3, please also jot down your hurdles in the notes sections of the Hotspot Mapping Spreadsheet. Hotspot mapping is limited to 100 parts, so if you need more, please let us know. To fill in the form correctly, you need all parts disconnected and you need to have a weighing scale, preferably with a precision of 0.1 grams. In most cases, a general kitchen scale will do, but if you have a more precise scale, it will be even better. Assignment 4 consists of producing the disassembly tree. You can make it very fancy using software tools, but a sketchy tree with sticky notes is a good starting point, where you can make changes in the layout very easily and finish it off in software. More about you can find in the Hotspot Mapping user guide. So to wrap this week's feedback up, I wish you good luck with the upcoming assignment 3, 4 and 5. And we advise you to try and stick to the deadline. If you're late, we cannot give feedback on your deliverable, but you will always learn from others' mistakes or inspirations. Don't forget to download the Hotspot Mapping user guide, in which all attributes of the Hotspot Mapping are explained and tips are given to help you through the process smoothly. It also contains handy redesign strategies after you've finished the hotspot and disassembly mapping. We hope to see you next week. Good luck with assignment 3, 4 and 5.